Today, we're going to talk about estimating dozer production off-site. This is an important part of putting a bid together because you do not get to go on the site to do the work until you've successfully bid. And in order to successfully bid, you need to know how much work you're going to do and what it's going to cost. And so we need to have a few pieces of information when we go to make this estimate. The first is we need to have our length of haul. How far are we trying to move the soil? The second is we need our equipment type. The equipment type tells us how much work the equipment is going to be able to do. Even though it's a Caterpillar designation, we still use the older, we still use the term even for other people's equipment, which is a D for dozer and a number. And as that number goes up, the capacity gets larger. So of course does the cost. So a D6, a D7, and a D8, as this number is increasing, this is a higher capacity. And if you go from 8 to 7, you have a lower capacity. We also need to know the material that we're moving. So if we're moving soil, we need to know something about the soil. We need to know what its bank density and its loose density are. We need to know how good our operator is. Number 4. Number 5, we need to know how we're going to do it. Are we going to do slot dozing? Are we going to do side-by-side dozing? Are we going to just do a single blade? What type of blade are we using? Because the blade will give you different capacities based on their shape, and we went through that in the previous lecture. We also need to know our operating conditions. Is it foggy and windy all the time, and there's deserts, the sandstorms blowing, and therefore it's difficult to see? Or are you destroying Bambi's forest, and so it's easier to get around, but there's lots of bugs? And then we need to know our efficiency. And if you recall, our efficiency is given to us in minutes per hour. So these are minutes worked. So our efficiency could be 45 minutes, it could be 50 minutes, it could be 30 minutes, all depending on how we're going to estimate things. And it's these properties that become important for estimation. Once we have these types of pieces of information defined, we can go from there to estimate our production. And the way that we do that is using two curves. The first here is our job conditions correction. The second curve is based entirely on the equipment that we intend to use. And so I'm going to arbitrarily select a piece of equipment that I'm going to use here. And if I do that, you can see that this is what this curve looks like. On this curve, we have several things. This is the average distance that we're pushing in one direction. It also includes, of course, coming back. This is my estimated dozing production in loose cubic yards per hour using a universal blade or a U blade. And each of these curves shows a different piece of equipment. This is a D7E, this is Caterpillar's data, all the way up to a D11T CD. All of these numbers afterward, or letters afterwards, mean something, but it allows us to make an estimate. So let's take an example and show you how to use these curves. Okay, so here we go. We have soil that has a loose cubic yard density that is equal to 2,700, there you go, 2,700 pounds per loose cubic yard. We're going to slot those we are going to have good conditions, an average operator. We are going to have 50-minute efficiency. And right now we're going to pave on a flat, or we're going to doze on a flat surface, no grade. So if I know that, and and I'm going to push 150 feet. So given that, estimate what my capacity is in loose cubic yards per hour. What am I going to be able to produce? Estimate production in loose cubic yards per hour. Well, the first thing I need to tell you is, well, I'm using a D8. So I go to my curve and I say, well, okay, I have a D8. D8T is curve E. I'm pushing 150 feet, which is here, and so I come up 150 feet till I hit curve Echo, which is right there, and I read over, and I'm able to do about 633 loose cubic yards per hour. So that's pretty good. So my base production is equal to 633 loose cubic yards per hour. Now, you'll notice that maybe you thought that was 625 and maybe you thought it was 640. The word estimate is in here, right? So we're attempting to see how well we think that we could do. Once we have all of that information, we now need to look at how things are going. And let's start with our correction factors. The first is, how hard is it to cut? I look at the geotechnical report, and in this case, the clay that I'm pushing has a blow count of 5. That's not very hard to cut. So up to 10 is easy to cut, up to 30 is difficult, up to over 30 is going to be hard packed and difficult to cut. So I pick up my correction factor. Here's my material. It's a loose stockpile, it's hard to cut, it's hard to drift, or very sticky material. It's none of those things. So when there's no factor there, we say there's no correction. So our factor is equal to 1. Our second correction, our grade correction. We get a grade correction from this curve. We said our grade was 0, so our grade correction factor is equal to 1. If in fact we had a different situation where we had plus 10 or plus 20, in other words we are grading uphill, then we would have a value that's less than 1. Grading downhill, a value that's greater than 1, because if we're going downhill, gravity is helping us cut. If we're going uphill, then we're having to fight against gravity. There is no rolling resistance on tracked dozers, and these are tracked dozers. Our next correction is for slot dozing, how we're doing things. So if we do slot dozing, we look up our correction factor for slot dozing is 1.2. Next correction factor is conditions from visibility. Conditions we said were good, right? Good conditions. So good conditions is 1. We have an efficiency correction. Our efficiency correction, we said at 50 minutes per hour is 0.83. This is equal to 50 over 60, right? This is equal to 0.83 from the table, which is 50 divided by 60. Our sixth correction factor is our operator. We said we had an average operator. The correction factor for an average operator is 0.75. And then finally, we have to correct for our material, because those production curves are set up with a particular material, particular density. And in this particular case, we are using a material with a loose cubic yard density of 2,700. The curves are based on 2,300, so our correction factor is equal to 2,300, this is from the curve, divided by our density, which is 2,700, and if we run that through our abacus, we get about 0.86. That's all our correction factors. We can go on from there, and so we can now estimate our production is equal to our uncorrected production, 633, multiplied by all of these correction factors. So our correction factors is 1.0, 1.2, grade correction is 1.0, conditions correction is 1.0, efficiency is 0.83, operator is 0.75, and our material correction is 0.86. If we now run this into our calculating machine, we will get a number. You should do this as an exercise for yourself. I will do it as soon as I get my calculating machine turned on. Calculating machine is giving me all my correction factors, 1.0.